Okay. So I just started the recording. So
Yeah,
we
hi
already
Karthik.
discussed about DevOps in the last video.
Hmm.
So today we are going to discuss about the basic fundamentals of DevOps. That is CI/CD. So CI is continuous integration and CD is continuous deployment. So we are going to discuss about both of these things. We are going to discuss the basic things about all these 4 points which I mentioned here. So what is continuous integration and what is continuous deployment and what is Docker and what is Jenkins. So um, so let's start with continuous integration. So that is the core of DevOps. Um, so I think in the last video we discussed about um, how can we create um, how can we create a website and how can we use that party hosting provider to host our website and all those things, right? So we discussed about different teams like development team, operations team, and testing team, right? So um, so that is where continuous integration will come into picture. So nowadays everybody want to do everything faster, right? So for example, developer is creating his code. So once he creates the code, tester then takes the code, tries to deploy in his environment and does his testing. Then operation guy comes into picture. Then he takes the code. He again deploys that into infrastructure. Everything happens manually, right? So what if all of them happens automatically, right? So there are two parts here. One is continuous integration. Another one is continuous deployment. So what is continuous integration is when the developer writes code and when he commits to Git, somebody triggers the uh, automation manually, or it happens automatically based on our requirement. It based on the project. So, for example, if developer is creating a React.js project and he is working on React.js project, so once he does some changes, he wants to see, for example, he is adding a new image in the website, or he is adding a new table in the HTML. So he wants to see how it's displays, how it feels. So to do that, he has to build the code and create a build code. There is a code and there is a build code. So what the build code is actually called artifacts. Okay, so there are different terminologies, right? So there's something called artifact, right? The artifact is nothing but a code which is built. Okay, so for example, in React.js, it will be in the form of CSS, JS, and HTML, right? So React.js and AngularJS, all these are uh, kind of framework that allows us to write code in some format. So we develop using the format so that it will be easy to create websites. So once everything is done, we from the React.js actual code, we for example, if I open just to give a better understanding React.js website, and I go to React.js. So if I go to documentation, and if I go to so there are different features here, right? You can see all these are different features of React.js, but we are interested in how to build and how to generate artifact from this, right? So maybe you have to React.js build. Let me see if I can find the correct. So there are so many things going on here. I don't want to get into details of all of these, but so at the end of the day, it's so we have a code, React.js code. We have to execute some command, and that will produce the artifact. Okay, it will be something like npm build. So npm is a node package manager. So basically node.js is a javascript engine. So react.js is a javascript library, so we write code in javascript. So node.js is a javascript engine to run javascript in the backend. So npm is a node package manager. So Sagar, are you aware of yum install or apt-get install?
No, no.
Okay. So so in Linux you might have done this, right? So how do you install a software in Linux?
Normally, we used to get the commands.
Yeah. So for example, okay, let's so to tell what is continuous integration, all these things are required, right? So that's why I'm going into all these things, right? So
okay.
just bear with me for a couple of minutes. So if we have to understand all these basics, right, then only uh, we can understand how continuous integration works, how Jenkins works, and all these things, right? So for example, I want to install Apache, okay, in CentOS. Okay, is this a simple example or should I search for something else?
It's a simple example.
Okay, Apache installation in CentOS. If I search for this, so I'm getting some link. So let's go with the first link. Are you seeing the Zoom, these commands?
No, I'm seeing the full screen.
Okay, fine. Yeah. So if I scroll down here, you can see these two commands, right?
Yes.
M update httpd, m install httpd. Right? So
yes.
So forget about this. Just ignore all complicated stuff. Let's just focus on this simple and basic things. So it's saying m install httpd. So that's all it's saying, right? So it's just saying just few commands, right? The core command is this m install httpd, and it's saying some firewall. If you want to just configure firewall, it's telling configure the firewall. Then it's telling start your service. Then Apache is running, right? So that's all it's telling. It's just telling very simple commands and only limited commands, 2-3 commands. So this is the core command and what it is doing, right? So this is what we have to understand. So so here we are seeing yum, right? So yum is a package manager. Okay, yum is a package manager for Red Hat, CentOS, Fedora, and different kinds of um, this Red Hat based Linux versions. So CentOS is one of the Red Hat based Linux versions. There are different Linux flavors, right? So one of the Linux flavor is Red Hat based Linux flavors. So Red Hat is a paid one, so you have to pay money for using Red Hat Linux, and CentOS is a free one. So CentOS is kind of open source. Anybody can take it and use it from internet. So this yum is a package manager for CentOS, right? So what does that mean is, so let's understand what is a package manager, right? So package manager is nothing but, from the name itself we can understand uh, it's a tool or it's a service which manages the packages. That is what package manager, right? So if I so there is something called CentOS mirror list, right? So if I go to this, so let's go to any one of them. So these are all nothing but these are all servers. Okay, so so these are all servers which hosts CentOS packages, or the packages which we can install into CentOS, right? So if I go to one of them, for example, anything, so they have servers in different places, so that see, if you see, there are 61 pages. There are so many. See, in India also they have servers, right? So that is true. So from India, if I have a server in cloud which is hosted in India, so I can use the server, so it will be faster, right? See, Sivanada University.
Mm.
So they collaborated with this university guys, and they are managing this. It's taking me to Sivanada University page. Okay. So let's go to mirror link. So right. So if you see CentOS.mirror. So Sivanada University.edu.in, snu.edu.in. So if you see here, there are different versions of Linux. Different versions of CentOS. For example, if I go to CentOS 7, and if I go to, I don't know which is the correct location. I think this is the one. Yeah. So if I go inside this, it's loading. So here you can see all the packages, right? So each of the file and each of its size, right? So if I search for what is the package we try to install, Apache. So it is searching because it's still loading. See, and Apache we are seeing, right?
Okay.
So what is this means is, so I want to install, okay, it says HTTPD, right? Not Apache. I think HTTPD, it will take some time to load because it's still loading. It's a huge page. Anyways, so what it is, so from this, what I'm trying to tell is, so when we say M install HTTPD, so M is a package manager. It is trying to download and install a package called HTTPD. Okay, from internet. So we cannot tell simply internet, right? So from in internet, from where actually it is getting, that is another question, right? So for CentOS, there is a mirror list. These are the mirror list. Like these many servers are there, right?
Okay.
So by default, when you install a CentOS, in m.repos.d et/etc/m.repos.d, in that directory there will be a file. Okay, in that file, one of these, we have so many mirror lists, right? So from all of these, there will be a default mirror list, which may be in US or UK, I don't know where exactly. So that will be the default mirror list. That mirror list HTTP URL will be configured in m.repos.d, etc m.repos.d. Okay.
Okay.
So when we say m install HTTPD, m will use the file which is inside etc m.repos.d, and it will download the package list. So M is a package manager, right? So it has some intelligence on how to search, how to download, and all those things, right? So when you say M install HTTPD, it will go and check in the default mirror list, which is configured in m.repos.d configuration file, and it will try to hit the URL and check if there is any package called HTTPD, right? So here, so for example, in the Sivanada University's package manager, hosted package manager server, this is the RPM file for HTTPD. So basically what it will do is, it will download the HTTPD RPM file, it will install the file. That's it.
Okay.
Okay, so to install RPM, we have to say RPM -i, and so RPM -i means RPM is a command, -i is install. And if we say, for example, you can, instead of package manager, using package manager, you can do something like, you can download this file into Linux. You can download this RPM file into Linux machine, and you can say RPM -i. Then it will install the RPM file.
Okay.
Right. So again, what is inside the RPM file? There will be a bunch of code which is built code. For example, if Apache web servers code is written in C language, that will be compiled and compressed into RPM file and kept here.
Okay.
Okay. So that RPM file we are taking and we are using it. So this is already compiled. So basically RPM files are compiled code, which is uploaded directly, so that we can straight away download and install. So we don't have to do manual compilation and all those things.
Okay.
Right. You can always, if you are interested, you can always go and download, since Apache is open source, you can always go and download Apache source code, and you can use make. I think you might have aware of make, right? We will use to build C
Compile the
source
code.
code. Yeah,
Yes,
so
make
we
file.
can build and you can use that to run Apache, but you don't have to do all this complex work. So that's why these people are managing these RPM files. So to have these RPM files, there should be a server somewhere hosted, and the server should host all these files. So when I say install HTTPD, it will download from there.
Okay.
Right. So that is what it is, right? So what I am missing here? Yes. So I was telling like RPM minus I, right? So you don't have to, again, you don't have to do make install or make configure and all those things. You don't have to even do download the RPM file and say RPM I. So all these steps are complex steps are abstracted into the single command.
Okay.
Right. So that is what the package manager's job. Okay. So different package managers have different features. So this is how yum install works. Same thing for apt-get install. So apt-get is a package manager for Ubuntu.
Okay.
Okay. In Ubuntu Linux, if you are using Ubuntu Linux, we will say apt-get install Apache. Then for Ubuntu, there is a separate mirror list. There will be lots of mirror list. You can see Ubuntu mirror list. Like that, each Linux will have its own mirror list. Each Linux distribution will have its own Linux mirror list. See, again, there are so many things. Canada, China. So wherever we are located, we can use the. See, again, this guy Sonar University. I think they are doing good job with all this, working with all this Linux distribution, and they are hosting, right?
Okay.
So that is what it is. So why I am telling all this is, I think hope you understand what is package manager and how to install a package in Linux, right?
Yes.
Right. So why I am telling all this is, so Node package manager NPM, that is again a package manager for JavaScript.
Okay.
Okay. So npm JS. So if I go here, this is a JavaScript package manager, right? So what is the purpose of this? So for example, so let's search for what to search. React.js, right? See, you can see all these React Redux, React.js, and all those things, right?
Okay.
So basically, these are all nothing but a JavaScript libraries. Let's otherwise let's take a simple example like array something, array flatten. Okay. So you know about array flatten?
No.
So for example, so if you have array something like this, right? So you have nested array, right? So this is one array, and this is another array, and this is another array, and this is another array, and this is a nested array, right? So
Okay.
so flatten is a function this guy wrote. Who is this guy? Where is his name? Yeah, this guy wrote. This is the guy, and play come bray. So he's the guy, and he written some code in JavaScript. And that what it will do is, it will, if you pass a nested array, it will give you a simple array.
Okay.
That's it. I'm not sure this function is there in JavaScript by default or not. Maybe it's not there. That's why this guy wrote it, right? So so to write, for example, when you are working in a project, you might encounter something like this, right? You have to do something like this. So then you have to find out the logic how to do it. Then you have to implement on your own, right? That is one way. Another way what you can do is you can just search in internet and see the logic and copy paste a Stack Overflow or somewhere. That is second way. What is the third way? Third way is something like this, right? So there is somebody already written the logic and so this is the proper way, right? So instead of you search and copy paste, maybe you make a typo or you will make some mistake while copy pasting and all those things, right? So instead of that, why we have to do all complex things, right? So instead of that, somebody has already written this and he uploaded into this npm js, right? So this is how open source works, right? Anybody can write and anybody can put it in GitHub and anybody can. So even this npm js is a open source, right? So anybody can come and put their code in here, right? So he already written the code, he kept it here. So what I have to do in my code, I have to just say import. That is the example he's giving. So how you can use it, how you can use this. So how you can install this package, npm install, array flatten, save. That's it. That's all. This code will come to your local machine. Then you say import this flatten from this library. Then you call the function. That's all we have to do.
Okay.
Right. So this is a very simple example. So same thing for any complex thing, right? So for example, some guy wrote some code to in JavaScript. Some guy wrote some code like what complex example I can give. For example, there is a server and hosted by government of India. For example, I'm telling. That gives you how many corona patients are there for today, how many people affected with corona, those kind of information they are giving. Okay. And what I am doing is I'm using that API and I'm writing one JavaScript library to do like all sorts of different activities, right? Check, get me daily corona patients, active corona patients, get me daily cured corona patients, right? Get me last 1 month corona list, get me corona count list, get me last 1 month corona count list. There are so many different scenarios, right? So what I'm doing, I'm writing all of those things into one JavaScript library and I'm hosting here, right? So I'm abstracting all the logic in the backend and I'm just giving simple function calls to anybody come and use it, right? So what you can do is in your project, you don't have to again write the logic, you don't have to find the government website, you don't have to understand how to call that government website's API, how to pass and all those things. You don't have to worry about it. You just have to import my code. You just have to call the function what I am giving you. That's all, right? So yes, that makes the life easy, right? So that is what here with React.js is happening.
Okay.
Right. So basically, what people will do, see, React is a JavaScript library and all those things, right? So see, this is the command we have to do. So to install React, we have to do npm install React, right? Then you have to import into your project. Then you can use all the features of React. See, this is written by React.js is written by Facebook. So you can see it here, right?
Okay.
So why I am telling all this is there are two parts, right? So so in a continuous integration, there is a code which is written by someone in a project. So he may not be writing everything from scratch, right? For example, he is writing in JavaScript, for example. He may not be writing everything in scratch, right? So he may use all these different sorts of libraries, right?
Yes.
There are so many libraries here, right? Because anyone can upload here. So many people upload here and there are too many lists. We cannot even, I'm not sure if I can count. Even if I type array, see it's listing 13,268 packages, right? So like that, there are so many packages, so many things only for JavaScript. We are just discussing about JavaScript. Like that for Java, there is a package manager. So that is called Maven Central. basically Maven, you might have heard of it, right? Java Maven.
Hmm.
So Maven is a package manager. So Maven Central is a repository like CentOS mirror list, like npm JS. This is something, right? So for example, JSON, if I type JSON here, see, there are so many packages, right?
Okay.
For example, I want to parse, I, I want to do some activity related to JSON in my project. So I can use already written code from anyone else, and I can use it in my project, and I can um, uh, improve my I can reduce my development effort, right? So I can deliver fast, right? So instead of I'm writing everything, I'm just going to reuse which is written already,
Okay.
right? So why I am telling all this is, so basically this is what will happen in a real project, right? So developer will write code and they will use all sorts of these um different libraries which is there in available in internet, right? So
Yes.
let's come to this. So what happens in a JavaScript project is, so for example, let's create a simple directory, React.js practice or something. So nothing is there in this directory. So there will be a file called package.json. Okay. So there is a, so since it's a JSON file, you know about JSON structure.
No.
Okay. So JSON is just a key value pair. There will be a key, there will be a value. That's it.
Okay.
Dependencies. There will be a key and there will be something like this. I might be wrong about the structure. So key, this is the key, right? And value is an array, right?
Okay.
Array flattened. React Redux, right? So what I'm doing, so basically I'm creating a file called package.json and I'm mentioning these are all my development dependencies. So this is one of my dependency, this is one of my dependency, this is one of my dependency. What does that mean is I'm using all this library in my project, right? Since I'm using all this library in my project, so to build my code, I need all these libraries, right? So for example, so there is a project called Unleash. Uh, this is a JavaScript project. So let's take this example. Okay. Um, see this it's a Unleash is an open source software. Um, so it's a feature toggle. So forget about what is this software and all about this. Just focus on the package.json. So you can see here, right?
Yes.
So whatever JavaScript package who are writing, you go to any project, you can find this file, package.json. Okay, because for JavaScript, npm is the package manager, and npm, um, so npm understands this file, package.json, right? So like that, every package manager understands some configuration files, understands some structures, right? So even Maven have some structure. So in Maven, there is something called pom.xml. Okay. So in the pom.xml, we specify all the dependencies. Like that in JavaScript, so you can see here, right? There is something called dev dependencies and there is something called dependencies.
Okay.
Okay. So I don't want to get into what is the difference between all these things. So we can park that later. So let's understand this. So in dependencies, this guy is using this library and he is using this version, right? See, he is using log4j, log4js and node fetch and parse database URL. These are all different libraries written by different people. And Express is a web server. It's a popular framework to write Node.js project, JavaScript project. Okay, so what is happening is he is he is using all these libraries and he is mentioning all these in dev dependencies, right? So for example, if I go to one of the pull requests, you know about pull request?
Yes, bringing the code to our local. If we have already taking means whatever some means many people used to do the developments and they used to commit the code and they used to push the code to the Git repository. Once we pull, the code will come to our local system where we have the repository files.
That is Git pull. This is pull
Yes.
request. So pull
Okay.
request is a specific feature in GitHub. So what is pull request is, say for example, this is an open source project, right? For example, I actually I have, I'm not sure if I can find, I actually contributed this contributed to this project. That's why I opened this project. See.
Okay.
See, this is I contributed to this. So so for example, this is open source project, right? So, and for example, you found a bug in this project, or you want a new feature to be added to this project. Okay. So what you can do is, since this is open source project, what you can do is, this is a repository, right? So in GitHub there is something called fork. So you can fork, when you fork this, you will get one copy of this code into your own, under your own name. So then you can make changes to the code. Then you can raise a pull request to this actual project. If you see, so I created this pull request from my repository, my branch, to this unleash repository to master branch. Okay. So once I do this, there will be something called, so in general what will happen is, so whoever wants to contribute, they will make changes in their own space and they will raise a pull request. Okay. Then whoever maintaining this project, like whoever owner of this project, he will come and see, okay, so so whoever maintaining this project, then he will come and see, okay, these are all the changes this guy is made. Then he will read line by line, then he will understand, okay, this guy is doing for this purpose. So we have to give all the details here. So in title itself I gave like example. I created one sample example file how to do it. So he will understand this and he will come and review, and if you have any suggestion, he will say, okay, can you do this, can you do that, like that he will ask. So if you see in this example, he asked me to do something. Okay, then I did some changes. If you see, he asked this, then I did some changes. Then he will come and say, okay, everything is fine. Then he will merge. Then he will approve. Then he will
to the
merge.
master branch.
Right. Right. So this is what the future of pull request. So in this, if you see, there is something interesting here. I came here because to show this. So what's happening here? Right. So when I raise a pull request, by automatically it will trigger some jobs. Okay, it will run some jobs and it will validate, okay, some guy has made some change. There will be, so for this project, there will be, so whoever maintaining this project, he will create predefined test cases or predefined tests or predefined scripts which will run against the code I changed. Right. So then it will validate the code. It will check, okay, there are some issues here. So instead of, see, there are something we have to do manually. There are something which we can always automate, right? So whatever things can be automated, whoever managing this project, he will come and automate that.
Like I heard something about that Sonar Cube, right? So that used to check the code quality, and then it used to check the all vulnerabilities, bugs, and automated things.
Yes. So Sonar Cube will not automate. Sonar Cube is just a tool for code analysis, and it's up to us how we automate and push the result to Sonar Cube. Okay. So that is where this future is, right? So that is what here is happening. I'm just trying to find where it is ran and all those things, but I'm not able to find it. Anyways, So basically there will be a job kick in, and there are so many open source tools like Travis, like Jenkins, right? Jenkins is a famous one. So there are so many CI tools, Travis CI. See, because open source is become too famous, so what these people, right? So Travis CI is a CI tool. So what these people will give us is, if I am writing any open source project, if I am writing something in GitHub, you can use Travis CI for free. You don't have to pay, right? So that is how these guys market their tool. So Travis CI, one of the tool, you can use it, like use it for open source project for continuous integration. So what is happening is, there are basically what is happening is, when some change happens to the code, there are some predefined jobs which kick in, which runs predefined tests. It can also automatically do build, right? It can build and keep the built artifact somewhere, right? So it all happens automatically, or you can come and trigger manually, whichever is feasible for the project. So when something happens, some changes happens to the code, something is building the code, verifying the code, right?
Yeah.
That is what is continuous integration.
Okay.
That so it's a general term. For why I explained all these things, because for JavaScript, the continuous integration steps might be different. For Maven, Java, it might be different. Even in Maven, there are so many different frameworks like Springboard, Spring, Hibernate. There are different frameworks, right? Everything there will be a different. How we build, how we do continuous integration. Even in JavaScript, we have React.js, we have AngularJS, right? We have Next.js, right?
Okay.
There are so many libraries nowadays. We cannot count. There are unlimited libraries. So it's specific to the project. What are all the steps we have to execute as part of the continuous integration?
Okay.
Right. So for example, this is how we build and start the React project in the local. So if we have to build, we have to execute something like npm build, right? So for example, let me just copy the proper JSON file. So let me install. So when I say npm install, right, first let me see if I have. I don't have npm. Let it run in the background. So what will happen is, when I say npm install, it will check for package.json in the current directory.
Okay.
And it will look for all these dependencies, and it will download the dependencies from npm.js, that node package manager mirror list, and it will keep it in local directory. Okay. That is what npm install will do. Then we have all the dependent library downloaded and kept ready. Now we can do build. We have to say npm build. Okay. So these are all the two different steps we have to do to build a React.js project. And there are so many different things, right? So I don't want to get into all sorts of complications now, but this is the basic. Yeah, you have some question?
Yes, sorry to disturb. Now what happening is, you are trying to install the node package manager, I mean the npm.
I'm trying to install Node.js.
Okay.
So when I install Node.js, npm will come by default.
Okay.
So yes.
So you are going to write, means for writing the JavaScript code, you are installing the Node.js.
That's correct.
Okay.
So again, so there are so many. There are so many basic things we have to understand, right? So that's why you see, we thought of we will complete everything in an hour, but we already took so much time to discuss this, because that's why. So without understanding this basic stuff, right, we cannot do anything. That is why people are struggling, right? Without understanding the basic stuff, they will straight away. Some people will tell, okay, Kubernetes is the famous tool. Just learn that, right? So you cannot learn Kubernetes without knowing Docker.
Okay.
Right. You cannot learn Kubernetes without knowing how crowd works, how the deployment happens, and all those things, right? So if you start learning, you will keep on hitting somewhere. You won't learn anything. You will only waste time. So let's see if it is installed. So hope it is clear, right? Okay.
Yes.
It's some error. Okay, we will come to that later. So you understand this, right?
Yes.
So for example, let me show some Java open source project. Which project we can take? So Springboard is a Java framework, which is used in many of the companies. So it's a famous one. So see, people are asking, right? Like how we are searching, people are asking, is there any projects? So he is telling, see, there's a guy called Ramesh MF who, who written this project. So what this project will do, it's something Spring IO site reference application, something. So basically he is using Gradle. So Gradle is a different build tool, right? So let's not get into this. I don't want to get into so many things and confuse. Let's see if I can find anything which uses Maven. These are all GitHub links. Let's open some of them. See, this is IoT project. This is a Kafka client. There are so many things people are writing, right? So okay. So this guy is using, see, already 2,000 people like this. So it seems like this is a famous project. So it's a Kafka web UI, right? So Kafka does not have by default any web UI. So this guy written this. So if we are using Kafka in project, we can use this open source tool, which will be useful. So why I came here is, so if you see Travis.yaml, I talked about this, right? So this is a continuous integration file for Travis.
Okay.
Same way for Jenkins, we have Jenkins file.
Okay.
Right. For every CI tool, there is a code, or there is a see, in Jenkins it's a code, but see, these guys, Travis CI guys, what they did is they written everything in YAML. You don't have to write code. Just give me the commands. They will take care of everything in backend. So that is how it's software industry is moving, right? So you don't have to do complex things. Everything is abstracted. So you just have to do what you have to do. You don't have to struggle. So let's understand this. He is telling language is Java, right? Even I don't have so much experience. So just understand. So he is telling language is Java and OS is Linux and services is Docker and JDK version is this, right? So he is telling what are the dependencies he have in his project. Then he is telling where to catch Maven packages, right? So and from where to build the code. So he is telling only from master build the code. Don't build from anywhere else. So on install, this is the main command, right? So Travis retry Maven dependency resolve, right? So like npm install, when I say npm install, what it is doing, it is going to internet and going to npm.js, downloading all the dependencies and keeping it in local, right? Same thing. Correct. Maven dependency resolve will do. It will pick the Java dependencies from palm file. So here he have mentioned different kinds of stuff. So there is a library called protobuf. This is a very interesting project Google is created. So many people have started using it. Even I have to learn about this. So he is using Google protobuf. He is using Apache Camel. He is using Springboard. So all these different Java dependencies he is using, right? So So this command will take pom.xml and it will try to install it in the local. It will take it from Maven Central. Then he is executing a command called script.sh. So the script.sh he written, you can find it here in script.sh. He written a shell script, and he written a complex shell script, and he is building and doing all this complex stuff.
Okay.
Right. So so if you see there are so many complexities going on here, right? This is what the jobs of DevOps guys. So DevOps guys have to do all these things.
So this automatically configures and downloads the dependencies and start the scripts.
Scripts and yeah, so whatever written here it will install. So he is doing Maven package Docker build. So from Maven itself he is building the code, and he is creating a Docker image. Maybe so he is downloading something from bittray.com. He is downloading some packages from he is downloading a jar file from bittray.com, right? And he is doing Maven deploy. So it will copy the build code somewhere. So all these complex things he is doing. See, he is also doing Docker push.
Okay.
Once he builds his Docker image, he has to push it somewhere. He has to store the image somewhere. So he is pushing here. So basically, he is pushing in Docker Hub. Docker Hub. So he has his own repository.
He is pushing to that repository is build.
Yes. So okay, let's now. So you are clear about CI right now. At least, if not clear, you got some idea, right?
Yes.
So
like
you can
how
see
continuously these things happen.
That is what it's called, continuous integration, because it is integrating so many different tools. Maybe that's why they named it as integration, continuous integration.
Okay.
So it's using so many different complex steps, right? So that is why it's integrating different sorts of tools. So that's why it's a continuous integration. Again, there are so many different patterns, right? So for example, so you have to do Maven install, right? For that you need to have Maven, right? From where Maven will come.
So those dependencies will include that, right?
Where?
In our .yml file.
That's correct. Yes, that's exactly correct. So that's how generally we do. So we will tell, okay, I want these tools. One way is like generally what people will do is in Jenkins scenario. So where we will run Jenkins, we will run Jenkins in some server, right?
Correct.
So what people will do is people will install all the required packages in the server, Jenkins server itself.
Okay.
Then in the Jenkins file, they will just tell Maven install. So Maven is already there in the machine, so it will use the Maven.
Okay.
So that is one way, but that is not the. So that's how even we are doing in our current project, but it's not the preferred way, right? So what will be the preferred way? So what will happen if the server goes down?
We will have to.
So that is not yeah. So that is not a cloud native approach. So cloud native approach is if something happens to something, I have to be ready with whatever my infrastructure within 10 minutes or 15 minutes or 5 minutes, whatever time.
Yes.
Right. Yes. So that is where Docker comes into picture.
Okay.
So Docker will be used for CI as well. So, but I don't want to get into that. Okay, let's move to Docker now. So I opened this website, Docker Hub, right? I'm not sure if you're already aware of it. Can you tell me from whatever we discussed today and see this website, dockerhub.com. So read this statement, whatever these guys are giving, and tell me what is Docker Hub.
It says like build and ship anywhere, any application, anywhere. So it like we don't want to have any dependencies.
No.
So Docker will take care of all those things.
That is okay. So whatever we discussed today, right? Based on that, I'm asking this. So you see this all these different names here, and,
Yes.
and tell me what is Docker Hub.
So it is actually storing all the softwares, libraries, everything in Docker Hub. So whenever we wanted to, so already it is installed in the Docker Hub. Means the files are already available in the Docker Hub. So they will just give you an image so that you will just go to the Docker and use whatever software you want. You don't have to install again in your
okay. That's all okay. You are telling correctly. I'm not telling you are telling wrong. Whatever you are telling is correct. But you are giving explanation of what is Docker. What is Docker Hub, right? So okay, let me tell you this. So Docker Hub is a Docker package manager.
Okay. Okay.
That's why I explained about all those.
Okay.
Right now,
like npm Docker Hub will contain
not npm
manager.
Npm or CI tool, CI commands, CLI commands. So we discussed about npm JS. We discussed about mirror list.
Yes.
Right. So that's even at our university hosted one mirror list.
Yes.
So Docker Hub is a mirror list for Docker.
Okay.
Okay.
So here, this is where the files, software library files will be there.
So in terms of npm library files will be there in npm JS. In terms of rpm files will be there in mirror list, centralized mirror list. Right. In terms of Docker images will be there in Docker Hub.
Okay.
You got the difference, right?
Yes.
So what is this? RPM centralized mirror list.
Okay.
npm JS library. So that is nothing but a JavaScript code.
Yes.
JavaScript code will be compressed into zip file and that will be uploaded to npm JS. In terms of Docker images will be there in Docker Hub.
Okay.
So this is very, very critical to understand this, right? Because in Kubernetes there is something called Helm. Okay. Helm chart. So that will be stored in Helm repo. Okay. In terms of Helm, it's called Helm chart. That will be stored in Helm repository. Right. So like this, there is so many examples, so many different tools in terms of Maven. Jar files will be stored in Maven Central. Okay. So what other tools we have? Whatever, for example, Go. I don't know about. I don't know where they keep. Okay, I don't want to get into that. Anyways, so even Go have their own package manager, which holds Go libraries. Okay. So you understand this, right? So that is what happens. So this is very critical, and every new tool which is coming up follows the same pattern.
Okay.
This is a successfully working pattern everybody follows. Okay. So even in case of AWS, see, Docker Hub is a public one, right? So see, I did not log into this website, but I'm able to see the Docker image. Right. So what will happen in a project, in an actual project? How do we store the Docker image? I don't want to store it in Docker Hub because it will be available to everyone. right? So there is something called see, in Docker Hub there is a pricing, right? So it's a free, it's unlimited public repositories. Anybody can come and upload image, and anybody can use whatever they want. But if you want private, you need to pay $5 per month. Unlimited private repositories. So there is something called public repositories, there is something called private repositories. So whatever images we seen so far, whatever images which is listed here, it's all in public repository.
Okay.
Right. So we also, Docker also provides private repository where you can pay money and you can use privately. Nobody else will see, only who have authentication to that repository can see that. Right. So same way, there is something called AWS CCR. So if I'm using AWS, right, my servers will be in AWS, and why I have to use Docker Hub to store my image? Because my server is in AWS. I don't have to. So when doing deployment, your servers will pull Docker images from Docker Hub, right? So we do have to. This AWS guys, what they did is, why do you want to store in somewhere else? I will provide you a repository service. You store your images in my AWS itself, right? So if you see, Elastic Registry is a fully managed container registry, easy to share image and all those things. It's nothing but a Docker repository.
Okay.
So you can store the image, and you can pull
So
from.
what?
Sorry.
So they will pull. Sorry to interrupt.
Yeah, ask me.
So they will your Amazon container repository will pull whatever the images. They will pull it from your Docker Hub and place it here.
No. That's not how it works. So, what is a Docker Hub? It's a server to store Docker image.
Correct.
Same way, AWS ECR in backend, they run some server to store Docker image. So in
Kind
your
of
application,
repository for saving the images.
Docker image, that's it. So it's called Docker registry. So that's a confusion, right? So this is the this is the trickier thing. In some place they will say repository, some place they will say registry. Just for this example,
Okay.
same way, if you take any technology, there will be a naming difference between some small word difference that will make us confused. Okay, but it's nothing but a Docker repository to store Docker image.
Okay.
And it's a private repository, you have to pay for it. You can, so if you want, you can make them as public, but those are all features of, see, you can see, go here and you can see the features. Okay. So they will tell, okay, you can do access control, you can do encryption, you can do third party integration, you can do all these things. So these people, at the end of the day, they are developing something, they are selling it to customers, so they have to provide different features. But at the end of the day, it's a Docker repository. That's it. In your application, for example, in Kubernetes, instead of pointing to Docker Hub, you can point to AWS ECR. It will, your Kubernetes is already in AWS. You will point to ECR to pull Docker image. Your Kubernetes servers will pull images from ECR. Everything is in AWS, so it will be very fast. Okay. And even for the security reasons, it's in AWS. So there are other different benefits, but the main benefit is everything will be in AWS. You can pull fast. Okay. So what we will discuss? So it took so much time. Should we continue or what?
For Docker. No issues. We'll continue.
Okay. So let's discuss. I think Node is installed. Now see, where is Node? Okay, Node is installed. Version. So I have Node, this version installed, right? So let's see what is the npm version. First, let's see if npm is installed. Okay, npm also installed. npm 7.5.3 is installed. So like I said, just take this. We'll take this example, then we'll move to Docker.
Okay.
So let's copy this and create package.json. Paste this, then do npm install. So you see, right? It started downloading the package.
So it used to download all the dependencies mentioned inside the package.json.
Yes, right. Because this npm tool can read and understand this package.json.
So as you said, like put key value pair, it will take that dependency and it will install all the libraries.
Right.
Okay.
So same way, when we say Maven install or Maven package, it will try to Maven will try to read the pom.xml. It understands pom.xml. It will download the dependencies.
Okay.
See, it is downloading all the dependencies from the. It's downloading. See, it will be fast. You cannot even read. It's downloading a string with all the. See, another. Um, so before moving to Docker, I will just tell you this. So that is where the complexity comes. For example, um, I'm using Express in my project. Okay.
Okay.
So it will be little funnier, but yeah, that is what it is. So if I go to npm.js, I go to Express. There are lots of even memes in Facebook. People troll about npm because of this. So what will happen? Let's go to so Express is another library which is hosted here, right? Which is the source code of Express is here in GitHub. So if you go here, there is a package.json here.
Okay. There is one more. So this will have all the dependencies inside for this Express.
Right.
Okay.
So that is it's that is the comedy here. So let's go to fresh.
So okay.
npm.js.
It's like writing the code and making a build, and again that dependencies, and again building 10 dependencies.
So let's go here and open this. This is the problem of I will not say problem, but it's the problem is there everywhere. But this is one of the problem of open source. See,
Okay.
and if I go to one of these, it might use again. So if I go to Mocha is a testing framework for JavaScript. So if I go inside that
will have again package.json.
So that's why it's taking this much time to do npm install.
Okay.
So this is one of the problem with npm generally, right? So there are tools like people come up with. There are tools like yarn. See, when I type yarn, it says yarn versus see yarn package manager.
Okay.
So when you open yarn, first word what they are telling is safe, stable. So where is the word? They told fast, right? Because npm is slow, right? So somebody came up with this idea. They did something to make this installation faster.
Okay.
Right. So even the guy who created Node.js, right? Node.js is created by someone, right? So see. So that guy understands, okay, there are lots of problems with Node.js. Then he created a new, for Node.js, to replace Node.js, he created a new framework itself.
Okay.
So that is how it is, right? So there are so many new stuffs coming. So we have to understand all new stuffs. that is how it is. So we have to learn everything. We have to daily learn something new. That's how it is. That's why I'm showing you all this. So let's see if it is
Okay.
installed. So there are some errors. Gadgets practice. I don't know what is the error, but I don't want to get into details. So so see, there is a folder created called known modules.
Okay.
Okay. So see, it installs 780 libraries.
Okay.
Not 780, maybe 778, 76. Yes. So if I go back, if I open my package.json, so let's see how many lines we have. From 66 to 100. So how much it is? 35, 36?
Around 35. Yeah, 34.
Yeah, so 35 libraries have internal dependencies, which led to 776 packages.
Okay.
So that is the problem of npm. So so what maybe that might have taken care in Dino or even Go language is there, right? So they understand this problem very well. They did some, so they changed how dependencies are resolved, change the way how dependencies are resolved. So every tool have their own patterns of how things are being done, right? So that's how. So let's practice. Let's do about. Let's do something with Docker, right? So in Docker, basically there is something called Docker file, right? You might have heard of it. Let's write something from Nginx or from Node. So I'm going to create a Docker image for my Node.js application, for example. Okay. Sankar, you there?
Yes.
Okay. So let's go to Docker Hub. Let's search for. We will just create this Docker image and we will close. Okay.
Okay.
So Node. So if you go to Node, so there is a Docker image already there for Node in Docker Hub. Okay. So if you see, there are so many different tags here because so for example, in my project, for example, I'm using now the latest tag, which is this.
Okay.
Right. So I will say in my Docker file from Node, pull this version, pull this specific version. Okay, that is the first line of my Docker file. Basically, every Docker file will have this as a first line from.
Okay.
What that means is you have to start somewhere, right? You are going to create a Docker image. So how will you create a Docker image, right? So that is one question. And why you are creating a Docker image? That is the second question. So why we are creating a Docker image? We are building a Docker image for my project. So what is my project based on? My project is based on Node.js.
Okay.
Right. So my project is based on Node.js. So I will start from Node Docker, Node's official Docker image. You got it or got confused?
Can you tell? Means we are going to use the Node.js.
See, I'm developing some software in Node.js in JavaScript.
Okay.
Okay. So to run my application, I need Node.js.
Correct.
So for example, my project is based on Node.js, JavaScript. JavaScript basically you have to run it with Node.js. To deploy this application in production, right? I need to have Node.js.
Correct.
Right. So same way, if you are developing Java project in your production server, you have to have Java. If you are
Yes.
having Go, if your project is based on Go language, in your production server, you have to have Go.
Yes.
Right. So basically, in production server, what we will deploy? We will deploy our Docker image.
Okay, so
right?
you will build, means you will build all those libraries for the running the node.js, and you will create a Docker image and you'll use the Docker image in all these environments.
Correct. So what I'm going to do, so in my production server, so I need to have node.js.
Okay.
So what my production server will contain, node.js plus my code, my JavaScript code.
Yes.
Okay, in my production server I want only these two.
Correct.
Okay, so forget about Docker. In normal, what we will do, we will just using SSH or something, we will log in into the server, we will install node.js and we will keep it ready. Okay, once my changes are for the first time production deployment, I will copy all my code into the server, then I will start node.js.
Correct.
Right. If you are doing changes, if you are adding features, what you will do, you will log into the server, you will delete the old code, you will copy the new code, then you will again restart the node.js.
Correct.
Correct. So now we are not going to use the default server. We are not going to install node.js in the server. We are going to use Docker. That is the use of Docker, right? I don't want to do all this manually all the time.
Correct.
Right. So for example, so how to say, so you have same thing we discussed in last video, right? So we have development server, and we have did already this node.js, and we have JavaScript code, right? So
Yes.
So while doing development, I logged into the server, I copied my JavaScript code, everything runs fine. Okay, now okay, everything is runs fine, testing is done. Now I'm moving to production, so there is a issue. Now same debate will start again, right? So everything works in development server, developer will say it's not my problem. Right. So what will happen is, it's not only about Node.js and JavaScript code. There is one more thing we have to install is dependencies. Okay. So something might have missed in dependency in production server, that is causing the issue.
Maybe.
Yeah. So that is one thing, right? So it's not only about these three things. There is something called configuration, app configuration.
Yes.
So these are the basic things. We might also need some sort of other things as well. So there are so many new things happening. There are so many things we have to manage between these and this. So doing this everything manually in the server, it's very difficult and very complex to manage and keep them
Sync
development, yes, sync and similar, right? So that is where Docker comes into picture. You package all these things into a Docker image. You do testing in your local with the same.
Okay.
In your laptop, you do testing with laptop. You do with Docker. Then you move the image to development server. Okay, once everything is done, you move it to production.
Okay, so the image only goes through all
the
environment.
Yes, because the image contain everything. So we package everything into a single file and we move to server. So that is the whole idea of Docker, and it solves lots of problems, right? So you got it, right? So
yes.
Now so okay, now talk about this. So now I have my code. So I have my code. So how do I create image?
By building it.
Okay, so what do you mean by build?
You need to compile and have the, means you need to see, like
right.
You said,
so in
writing a C program, we will do a make file and we'll take a build of that binary file. That is what the build, right?
Correct. So that is a build in terms of compared languages.
Correct.
Okay, there is something called scripted languages, right? That is example is JavaScript. In JavaScript, you are not actually building it. You are just doing some transformation, right? So assume these are all part of the build. So here what I'm doing, I have my JavaScript code. Now I need Node.js. So now I need dependencies. I need configuration. So I have to include all this to my Docker image. Then I have to create a Docker image.
Correct.
Right. So this is nothing but a Docker file. This is nothing but a Docker file.
Okay.
Okay. Same thing. I copy this. I copy here. Forget about all what I told earlier. So this is my Docker file. I assume this is not the correct Docker file, but this is how it's kind of a pseudocode or skeleton. Okay. Now I have to convert this into a proper Docker file, which Docker can understand. Okay. I explained to you this, so you understand this. Maybe I have to explain to someone else, that person can understand. But how will Docker understand this? So that is why we have to write it in a format Docker can understand. So first thing is I need to have Node.js, right? So that is what I'm telling from Node. This.
Okay.
So now I will my Docker my Docker image or Docker file will start from Node.js image.
Okay.
Okay.
That will take from 15 that version, whatever tag is mentioned.
Yes.
Okay.
So in Docker there is something called, okay, now it's a time to explain Docker layers. Now there is something called Docker layers. Okay.
Okay.
So in Docker, this is one layer. In Docker image, that is one layer. Second one is one layer. This is one layer. This is one layer.
Okay.
You understand it, right? That is a layer.
So it step by step.
Yeah, that's it. So for example, so in Docker generally, how Docker will how you have to write it is, whatever thing is going to change, you have to put that at the end. Okay. So when you create Docker image from this Docker file, what it will do is it will pull this image, then it will create image with the dependencies, then it will create images configuration, then it will copy your code, then you will create multiple layers, it will create image. Now you are making some changes in your code. Okay. For example, you are adding a new feature, and so that feature you want to copy into Docker image. So what you are doing, you are creating a new Docker image. So at that time, what it will do is it will check the Docker commands, the Docker file commands which you executed already. Since it will understand all these things did not change, it will just take the Docker layer from here, and it will only add your code, and it will create a new image. It won't do all this again and again. Okay, so that is a Docker layer. You understand now, right?
Okay. But my confusion is, as you said, like what if there is a change in configuration, like again those things will happen.
Correct, that's correct. Now forget about configuration. Okay. Forget about, even we don't have code in our example. Forget about. Okay, we will add some code just to, it will not be a proper code, but maybe test.js.
Okay.
Console.log my test. Okay. So node test.js. So it is just printing this.
Yes.
Console.log is just a print.
Okay.
Like printf in C. So that is what it is doing. So now, okay, let's go to Docker file. So I have this from my base image is there. Now I'm going to install dependencies.
Okay.
This is how I have, right? So now I have to install dependencies. So to install dependencies, I'm going to say what I have to do. Basically, I have to do npm install, right?
Yes.
So
Yes.
I have to say run npm install.
Okay.
So what it will do is it will create a Docker image from this image. It will start the image. It will create a container. So container is a running Docker image. Docker image is a static file. Okay. So
Okay.
from this image, it will create a container. It will run this command. It will create an image. So my image will be having two layers. One is this. One is this. You got it, right?
Yes.
Okay. Now I have this. Now I have to copy my code. I have to add my code or whatever word you want to tell. Right. So how can I add my code? Add test.js into from my local into container. Add it in / whatever path. What path we can have. Anything / my project. Okay. So it will add a code, right? My Docker file is done. Let's build Docker build dot -t my project version 1. Okay. This is my Docker image name. This is my tag.
Okay.
When I say dot, it will pick the Docker file from the current directory.
Okay.
Let's not execute. Let's do one thing. Let's rename my Docker file into Docker file Dhoni. Okay. Now execute Docker build. Okay. What it is telling?
Unable to evaluate. So
just read the line. Read this. Read
this
what
Docker file, no such file or directory.
So you got it right. It is trying to find a file in the current directory which is named as Docker file.
Docker file.
Since it is not able to find it, it is throwing an error.
Correct. Okay.
So this is very simple example, but this is the key, right? So if you understand this basic thing, you will in troubleshooting we will save lots of time. So Docker is a tool which expects something in some format, which that it did not find, so it's throwing an error.
Okay.
Right. So same thing will happen in every tool everywhere, right? So you have to understand how the specific tool works. You have to write your configuration or your code or your whatever, your YAML file or JSON file or Docker file or Jenkins file, anything. You have to write it in a format that tool understands.
Okay.
Right. Same thing, right? You have to write what is syntax error. You have to write it in a correct format. The compiler can understand. Otherwise, it will throw error.
Correct. Yes.
Right. Same thing. So now just rename Docker file Dhoni into Docker file. Now
Docker
build it.
file. Okay.
So sending build context to Docker daemon. So even I don't have full clarity on what is this exactly, but looks like it is just reading the Docker file and it is trying to send this information into Docker daemon. So Docker is a service, right? So so Docker is running as a service in my laptop. So using that, it is trying to build an image.
Okay.
Right. So basically, if I open new window, so ps -cf group Docker. So if you see, I have, so Docker is running so many different services, right?
Yeah. Okay. Many processes are running.
Yeah. So basically, Docker runs as a service in Linux. You know about service, right?
Okay.
If not, we will discuss that later. So the Docker. So this is one more command we executed. That is running as a process. Yeah.
It lists the current processes.
Yes. So I don't know which one is the proper Docker daemon. Since it's a Mac OS, it might have some different way of running Docker and all those things. In Linux, it might be different.
Okay.
So I don't know. It's taking this much time. Generally, it will happen very quick.
Okay. So this will give you an image which will have the
Actually,
node
yes.
package manager image, and then the
Not the package.
dependencies.
What do you mean by package manager image?
No, I mean for running the node.js, you have already taken the image of npm, right?
Not npm, node.
Node. So that one and the code, whatever you have written, that console.log. So both will have, and you will have that image file.
Right.
One file created. Okay.
So I think we are not able to come to this.
Okay.
But I think it was useful, right? But I want to let it run, and I want to show you something.
I came to know many things new about today's session.
So
yes,
maybe we can discuss about this next video. Maybe we will discuss when we can do it.
Yes.
So it's doing this, but I will explain that. Before that, so do you understand what is this now?
Yes, like continuous deployment is like we will be deploying the images every time.
Okay. So yeah, basically yes, basically that's what it is. So you build and create an image, that is your so I said about artifact, right? So that is your artifact. So so previously artifact, the meaning of artifact is like jar file, this compiled zip file, like
library
JavaScript
files.
library files, yes, and all those things. But nowadays, since Docker is becoming famous, Docker is the artifact. Docker image is the artifact.
Okay.
Artifact is a general term.
Okay.
So, okay, let's come here and understand this. So, what it is doing now? So step one, whatever Docker file we written, it took, and it's saying it is pulling the image from library node. That means it's pulling from Docker Hub.
Correct. Okay.
Then it says it's so the default Node.js itself have different layers. So it's pulling all the different layers. If you see, there are 4 different layers.
Okay.
That is because maybe we can speak about that later. But to just give you context, that is based on some base image, and they are installing Node.js into that, and they are having 4 different layers.
Okay.
So that is how this image prepared. So on top of it, we are adding our stuff. So it basically failed. Why?
Okay.
Because maybe the nodes. Okay, let's do one thing. Let's remove everything from. Okay, maybe. So we did a mistake. Can you find out what is the mistake?
No, means we are trying to means that node is already having the npm, so we don't have to again install it.
No, let me tell you. So we have this package.json, right?
In our local, yes. Okay.
Yes, in our local, but we are installing npm. We are doing. I mean, we are running npm install inside the Docker image, inside the Docker container.
Okay. Yeah. Yes. We are trying to install the npm inside that image, whatever coming
inside the container, right?
Pack. Yes.
So
okay.
How does it know about the package.json? It does not understand the package.json. It does not know where is the package.json. Okay. You have to copy the package.json inside the container.
Okay.
Okay, but there is also another problem here. So we are saying run npm install, but in which location we have to run, we are not telling it.
Okay.
So even if I run Docker build, it will fail because we are copying package.json into /my project, but we are running npm install somewhere else. We don't know. So there is something called work dir.
Okay. So you are setting a directory.
Yes. So then you can say dot. You understand now?
Yes, yes, yes.
Yeah. So this will be my working directory. So if I add this file to dot, it will be copied to my working directory. My run command will
Okay.
execute on this directory.
Okay.
Right.
So like okay, so this add work directory, run, all those things are
So
like commands. Okay.
just to make
Means
this,
adding to the container. Okay.
yes, just to make this faster, let's remove all this because we are not using anything. We are just
Yes, just we
writing.
are going to print.
Yes. So 60. Let's have only one, so that.
Okay.
So now run Docker build. So this time it should be faster because we already pulled the image. Oh my god, starting from. I don't understand why it's. So this is the problem, right? We will run into all set of new issues. So what do? We will wait or will.
No, means no issues.
It's already 240. Yeah, but it is required. So without, see, I can straight away show you Jenkins, and I can tell, okay, let's build a Docker image, deploy it. That's it, done Jenkins. But you won't
No,
understand the head and tail, right?
yes. Now I got little understanding about how actually a software comes into our OS. So first thing is that, and second thing is like what is image and how that image is coming into. I mean, how that image is getting built. Like how we went for package.json inside, right? So I get a little bit understanding.
Okay, so I have to find out. It's taking time. So maybe we will take a break. We will continue later.
Yes, yes.
Okay. So I will just keep this as it is. So we will continue this in next video.
Yes, sure.
Okay. Yeah. Let me
Thank you
stop
so much.
recording. Okay.